Hello. Okay, in this video, I'm going to show you how to build this weldment as an assembly without having to use the weldment toolbar. In industry, I preferred making weldments as an assembly because then I would create a separate configuration of that assembly showing both the welded version for the fabrication shop and the machined version for the machinists. So that's kind of how I'm going to design this weldment. As an assembly. So what I've done is in SolidWorks, I have modeled all of the components ahead of time. So the base minus the drilled holes. I have the column with a hole that's slightly smaller than the finished hole in the weldment. So I've got a hole here in my part that is pre-cut to 7/8 of an inch diameter. The finished diameter is 1 inch plus or minus a 64th. So if a machinist were to pre-drill this, or if this was flame cut or water jet cut undersize, it would allow me to finish the hole to 1 inch post assembly or post welding, and I'll explain as we get through it. The gusset's a gusset, so it's just a triangular piece of steel. And then the what I'm calling the boss in the back is just probably a piece of rod that was drilled through. It's 1 3/4 inches diameter with a 7/8 hole through it. You know, and if you could find tubing with this wall thickness, great. But again, I've left it undersized so that after this piece is welded here onto the column, I can almost line bore through both pieces, knowing that it'll be perfectly concentric and I'll be able to hit this tolerance and its location. So lots of benefits to keeping this hole undersized when welding. Okay, so here's my motor bracket weldment assembly. I've already have the inches, pounds, and seconds. I have the unit set up, and my overall drafting standard is ANSI. So the first thing I want to do is go to my assembly toolbar and insert my first component. Remember, don't insert your first component unless you can visually see your main assembly origin. Right now I'm in my main assembly. Here's my main assembly origin. I want to make sure that when I click this button, Insert Components, and locate my first component, in this case it's going to be the base, I want to make sure that I insert the base so that it's connected to the origin. So what I'm doing is I'm creating an automatic coincident relationship between the parts origin and the assembly origin. And when I bring my cursor near it, don't try to line up the origins because it'll never work. You have to bring your cursor near it. So once your cursor is near it, you'll see a double origin icon. That's when you can click. Now I know that my base component is fixed in the correct location. My planes match up, okay, and my origins match up. And now it's just a matter of connecting the rest of the components. I'll do the column next by inserting it anywhere on the screen. And I'm going to add a couple of assembly mates to define its location. So the first mate I want to add is between the bottom of the column and the top surface of the base plate. And then what I'd like to do is mate the back surface of the column with the back surface of the base plate. And now, if I hit this green check mark, the only thing that this can do is slide left or right. Now, if I want to maintain center and model this using design intent, I'm going to mate the plane that cuts through the middle of this component with the plane that cuts through the middle of this component. So I'm going to mate, and I'll expand my feature manager. In this case, it would be the right plane of the base component, and I'll expand my motor bracket column and mate it to the right plane of that component. So now and the reason why I say this is good design intent is if the customer changes the, let's say the width of this from 4 inches to 5, now I can change the width of my column from 4 inches to 5 without having to change any relations or update any further dimensions. You know, everything stays centered. And there's other ways around that as well. So let me hit that back to 4. And notice that when I make these changes dynamically, nothing's happening until I hit this rebuild button. Okay, so here's our weldment. Now I'm going to insert the gusset. All right. Now this was modeled using midplane, so if I mate the right plane of the gusset with the right plane of the assembly, it should stay centered. And then I just have to glue the two surfaces together. So I'll sneak in here and grab the back of the gusset here and the front of the column, and then the bottom of the gusset with the top face there. All right. So now it's fully defined. We have 3 fully defined components. And with a weldment, you don't want to see any negative signs to the left of your component. And then last but not least, we're going to put in the boss, which is on the back side. And I will add a concentric mate. And then a coincident mate. It does not matter if the component spins, but if you're going to lose sleep over it, let's mate the right plane of that component with the right plane of the assembly. So now everything's fully defined. This boss won't spin. I don't need to see the origins anymore, so I'm going to go to my View or Hide button and uncheck origins. I'm going to revert back to my isometric view and do a quick file save. All right, now I'm going to add these 2 drilled holes. If we look at the print, they're 3/4 inches in diameter and their locations are here. So let's just start off by using Hole Wizard. And I'm going to pre-select the surface I want to put the holes on. And from my assembly toolbar, underneath Assembly Features, I'm going to click Hole Wizard. And they're 3/4 inch diameter plain drilled holes. So I'm going to switch this from ANSI metric to ANSI inch. I don't want to see all drill sizes available. I just want to see fractional drill sizes. And then I want to choose 3/4 of an inch from this list. Hello, there we go. Through all. All right, sorry about that. Okay, so here's my 2 points. I'll put my normal to view on, and we are going to make these 2 points horizontal. And then I want to start adding some dimensions. So they are 1 1/8 from the center. So from the center of the part to the first hole is 1 1/8. And it's 2 1/4 from one hole to the other. So that takes care of the left and right locations of the holes. And then they are, well, it's either 2 1/8 or 3 3/8 from the back side. So I would go 2 1/8 from the back of the column. Okay, so that's that. I'm going to hit the green check mark, and we have 2 drilled holes. And because these holes were drilled after the weldment, I always like to click the feature and go to Edit, Appearance, and change the color. I like an obnoxious red. So there we go. So what this color is telling me is that these holes were drilled after the weldment. Then we're going to drill this out. We don't have to use Hole Wizard here, so I'm just going to use a regular. Look at this. Assembly context sketch notification. it's warning me that I have a sketch within an assembly. So that's what I want. So you can shut off that warning. Let's see. And we want this hole to be 1 inch plus or minus a 64th. So I can come over here if I wanted to be slick and add a symmetrical tolerance and type in 1 divided by 64. And then we'll say, we'll bump that. Actually, we can make this fractional. And we'll say 64. There we go. So now we have 1 inch plus or minus 64. If this was reamed, which I would imagine it is, I could come over here and say REAM and add that text so that when I go to make my drawing, my diameter is correct, my tolerance is there, and my machining operation for reaming is there. And then I'm going to go on my assembly toolbar underneath assembly features, just do a simple extruded cut. I want to say through all, but because I'm in an assembly, I have to say all components because I want this hole to go through both the boss and the column. And it does. It goes through everything. And I'm going to also edit the color or the appearance of this cut and make it an obnoxious red. There we go. Do a file save. And if you wanted to take a peek through the weldment by slicing it in half, you can. There it is. Okay, there's the through hole. All right, well, there it is. As far as weld beads go, you can add a weld bead in an assembly. I guess we should do it because I'm recording this. So let's go to the View Hide button. I'm going to view my weld beads. And from my Assembly Features button on my Assembly toolbar, I'm going to click Weld Bead. And then depends on what's going on, whether you use weld geometry or weld path. I always try to use weld geometry first because it gives you more options. The first selection I want to make is this face right there. And then in the second box, I want to choose, well, let's do the column first. And if the plate thickness is, let's see, 3/4, let's make the weld bead 3/8 of an inch. So there we go. There's our 3/8 fillet weld. Let's add some weld on this side. We're going to go all around here. So on my assemblies toolbar, I'll click weld bead. I'll click this face. The second box, I'll click its corresponding face, and I will check the all around button over here so that my all around symbol appears, and it's that little circle that's on the intersection of the reference line on your weld note. And then let's weld around the gusset because if we don't, then it's just floating in space, and we don't want that. So let's hit weld bead. This, I believe, is a different thickness. It's a 1/2 inch, so let's make this weld bead 1/4. So I'm going to click this as my first reference, and then this face. And then I'm going to click both sides over here on the left-hand side. So we'll get that out of the way. And then we'll do one more weld bead back here. Okay, there it is. You can move the weld notes out of the way. You don't have to look at the weld beads. I don't think they look great. SolidWorks, they remind me of a zebra, but now everything is welded. And I don't know. I think building weldments as an assembly is a little easier. Building each component separately, bringing them into an assembly, and then welding them versus using the Weldment toolbar. But I just wanted to show you a different approach. And this is lab 1 of week 2. Thanks.